Question 15 is asking us to determine the sum of the arithmetic series given by 3 plus 12 plus 21 all the way up to 597. So let's start with our equation for the sum of an arithmetic series, and that is S of n terms is equal to n over 2 times 2a, where a is the first term, plus n minus 1, where n is the number of terms, times d, which is our difference between each consecutive term. So to get the sum, we need to figure out some of these variables in this equation. So the easiest one to figure out is d, the difference between our terms, and we can do that just by writing out this series as a sequence. So we have the first three terms are 3, 12, 21, and the difference between 3 and 12 we can see is 9, and again between 12 and 21 we've added 9. So this means that our d is equal to 9. All right, so the next one we want to figure out is what n is. So we know that our last term is 597, but we don't know which number term this is in our sequence. So to figure this out, we're going to use our equation for finding the nth term, and that's where we have Tn is equal to a, our first term, plus n minus 1 times d. And so in this case, we want to figure out what n is for our term 597. So we're going to put 597 here. And we know a, our first term, is 3. Don't know n, that's what we're solving for. And we've just found out that our d is 9. Okay, so now we just solve for n. I'm going to multiply this 9 in to my brackets here. And this gives me 597 is equal to 3 plus 9n minus 9. And what I'm going to do is combine terms on the right side of my equation. 3 minus 9 is negative 6. And I have my 9n here. I'm going to add 6 to both sides of my equation. 597 plus 6 is 603, and that equals 9n. So now I'm going to divide both sides by 9. This gives me n is equal to 603 divided by 9 ends up being 67. So that means that 597 is our 67th term in the sequence. All right, so now we have everything to solve for the sum of this arithmetic series. So I'm going to do that on this side. What we have in our equation, I'm using this one up here. We have the sum of the first 67 terms is equal to 67 over 2 times 2 times our first term, which is 3, plus 67 minus 1 times d, which is 9. All right, and now we just have to evaluate this out. So 67 divided by 2 is 33.5, and 2 times 3 is 6, plus 66 times 9. It's 33.5 times 6 plus 66 times 9 is 594, and 6 plus 594 is 600, And 600 times 33.5 ends up being 20,100. So the sum of our first 67 terms in this arithmetic series is 20,100. And that's our answer.